Hi guys, welcome to your lesson on using the scientific method. So your learning intention, that's what LI stands for, is to use the scientific method to investigate the natural world. Your success criteria is that you can be successful if you can demonstrate your understanding of the scientific methods of investigation. So what is the scientific method? Well, it's a series of organized investigation procedures. And we usually follow these steps in roughly this order, but sometimes we change the order. We go back and revisit some of these steps as we go through a scientific investigation. So the first thing we have is a problem or purpose. Now that problem or purpose can be as simple as, what am I going to wear to school today? Or which way should I go to get to math class? Or what kind of grades do I need? How can I get an A in Ms. Skinner's class this year? That's your problem or your purpose. Then you do your research. Your research could be as simple as your past experience, or it could be looking things up in the book or on the internet. And be careful where you get your internet resources from, because some of them are not reliable. But research is necessary in order to make your hypothesis. And you've heard of a hypothesis before, an educated guess. An educated guess can be what you think will happen. But in our class, we're going to try to make sure we always use if and then statements. So if I wear shorts and t-shirts to school today, then I will be comfortable. Or if I go out Miss Skinner's first door, then I will get to math class more quickly. Or if I study every day and do all my homework, then I will make an A in Miss Skinner's class. Those are if-then statements that you will need to use in my class. So make sure you use them as much as possible. Sometimes our hypotheses have to be revisited. Sometimes we change our hypothesis after we've done a couple of experiments. All right, the next part of the scientific method that we're going to talk about is variables. And variables are used in experiments. An experiment is a test. Just like the test that you take at the end of the unit, that test tells me whether you understood everything and grasped all the knowledge that you were supposed to or not. Well, an experiment is a test of a hypothesis. An experimental design is important in order to have a valid test. If I gave you information about the scientific method and then the test I gave you was about physics and Newton's laws, would that be a fair test? So we've got to make sure the test is fair. So there's some things that we have to worry about. The first thing is independent variables. Independent variable is called the manipulated variable. And I put a blue I there to remind you that's the one that I decide or you decide. This is the variable that you decide what it's going to be. For instance, if I want to know how far or how fast a ladybug can travel when they're crawling, then I can decide whether I want to measure that in millimeters or centimeters or even meters. It's my decision. That's my decision, and that's my manipulated variable. All right, that's what I decide. Sometimes you might choose a different type of variable to be your independent variable. For instance, if I was going to decide what kind of popcorn was the best kind of popcorn to eat, if I was going to use microwave popcorn and I want to decide what brands I choose, that's my independent variable, the brand of popcorn that I choose. The dependent variable is what you measured, or your responding variable. All right, you're going to measure something. So let's talk about the popcorn. What are we measuring? We're going to measure how many pop kernels you get out of the bag. So that's your dependent variable, the one that you measured. Now, the two variables, or the two things that are most confusing in this scientific method is something called the constant and the control. The constant is something that in the past your teachers might have called the controlled variable. A controlled variable is not the same thing as a control. So I've got a comparison here. A constant is called a controlled variable, but it's a condition that is kept the same during the experiment. A control is something you might call normal, and it's a standard used for comparison. It's not something else, okay? It's not a variable It's something that you use to compare to. Now here's an example of constants and controls. I've got 4 plants here. Each plant receives what? They each receive H2O. You've heard of H2O, that's our good friend water. And some of them have some salt. This one gets 0.5 grams, this one gets 1, this one gets 1.5 grams of salt with their water every day. I've labeled this one as low salt concentration, medium salt concentration, and then highest salt concentration. And this one I've left normal because I'm not giving him any salt. This experiment might be done to determine what effect salt concentration has on the growth of plants. So my purpose was to see what effect it had, and my independent variable is how much salt I give each plant. I decide that I want to give this one 0.5 grams, this one 1, and this one 1.5. I could have decided that I wanted to give each one of, well, this one 10 grams, this one 20 grams, and this one 30, but I decided I just wanted 0.5, 1, and 1.5. Since I decided it, that's the independent variable. All right, now, what is it that I'm measuring about these plants? Wouldn't I want to measure the growth? The growth of the plants over time, depending on whether they have low salt, medium salt, high salt, or no salt, is called the dependent variable, the responding variable, what I measured. All right, and now let's talk about those constants and controls. What is constant for all 4 of these plants? Well, each one of them has the same amount of water. Now, I didn't put it on there, but the same amount of light would be good, constant to have. The same type of soil. You'd want them to start at the same height, and you'd want them to be in the same amount of water. All right, everything needs to be the same. Those are called constants. Remember what we call constants? They're the controlled variable or constant, and they're kept the same during the experiment. So all the plants get the same amount of water, sunlight, soil, the same type of soil, the same size pot. They start the same size. Now what about the control? Well, there's one control on here, and that's this little dude right here. He is normal. What are we going to do? We're going to grow these plants, and then we're going to compare them to this guy. If this one grows about the same as this one, and this one doesn't, and this one doesn't, then we know that the higher salt concentration makes it harder for the plant to grow. Well, what if it doesn't turn out that way? Well, then we have to go back and rethink our hypothesis. And we have to change our hypothesis to reflect what we think would happen in the next experiment. And then we'd repeat the experiment over and over again. Well, there's more to this than what we've talked about, so let's stop right here and we'll come back later and get the rest.